This video will cover the third page of notes on the topic Applications of Logs and Exponents. In the last video, we covered a PERT, where we had an equation that said A is equal to P times e to the RT. In this video, we're going to talk about growth and decay equation, and we're going to have this equation that says y is equal to y sub 0, or y naught, times e to the kt. And we should see that these are the exact same equations. The only difference is that we change the letters to protect the innocent. In other words, y is going to be our new amount, or our new amount after we leave our principal into the account for a set number of years. Y naught is the original amount, or P, our principal, the original amount that we put into our bank account. We had R, and it represents the same thing as K, which is our rate. And the big thing that we're going to see here is that if K is a positive number, then we have a growth, an exponential growth happening. If K is a negative number, then we have a decay happening. So I just want to remind you that an exponential growth graph looks like this, where it's increasing. We see that with the coronavirus. And decay would have a graph that looks something like this, where it's going smaller and smaller as time goes on. So that's the new thing here, is that our rate can actually be positive or negative. If it's positive, it's because it's growing, like bacteria. It's negative, it's because it's decaying, like fossils. And then the last thing is t, where t is time, and that is the same for both equations. And again, it's going to be by year if the rate is given in terms of year. So our first example for this video says the bacteria grows according to the law of uninhibited growth according to the function n of t is equal to 108.3 times e to the 0.012 t. And n is measured in grams and t is measured in days. That means our rate has to be in days too. How long will it take the population to reach 150 grams? So they gave us our equation, and I want to make sure we understand what it means. We can see that we have n of t, that's going to be our new amount after some time. The 108.3, that number is actually representing P, or our Y naught, or our initial amounts. In other words, we're starting with approximately 108.3 bacteria. Now, how does you get 0.3 bacteria? This is most likely an average of bacteria that they had around the starting point when they took a couple of days into consideration. And then we have K is this rate right here, and they kind of tell us, they don't tell us the rate, but we can put this into percentage and notice that this is about 1.2%. So that's our rate. Because it's positive, then we know it's an exponential growth, and they kind of tell us that in our problem, that it's growing. And then t is going to be the number of time. In our case, it's measured in days. And that's because our rate is probably increasing at 1.2% per day. And so that's the reason why t will also be in days. All right, so our job is to find out how long it takes to get to 150 grams. So that's what we want at the end. This is how much we started with. This is the rate that we're going to use, and t is going to be the time that we're looking for. Just like we did in the previous video, where we're looking for our variable and our variable is in the exponent, is that we need to isolate that. So we have 108.3 times e to the 0.012 t. So we're going to divide both sides by 108.3, and that's how we get this equation here. Now we have to get the same base, in which we can't, so we're going to take the natural log of both sides. So that's what you see over here. We're taking the natural log of the quotient 150 divided by 108.3, and that equals to the natural log of e to the 0.012t. Using the third property of logs, I'm going to get my exponent and put it to the front. And now you see that I have my natural log of my quotient of 150 divided by 108.3, and that equals to 0.012t times the natural log of e. But remember, the natural log of e is equal to 1, so we're just going to have 0.012t is equal to the natural log of my quotient 150 divided by 108.3. Last thing we need to do is to get t by itself, so I'm going to divide both sides by 0.012, divide both sides by 0.012. And again, I want to remind you that we can leave it in this exact form. If we wanted to get an approximation, we can use our calculator and input this into the calculator and find that it's going to take a little bit more than 27 days to get to that amount of bacteria. And finally, the last example says if we have 600 grams of radioactive substance are present initially and 3 years later we only get 300 grams, the question is how much of the substance will remain present after 7 years. So we know that at 3 years we had half of it left. The question is what happens after 7 years. So let's take a look. We're going to use our equation here for exponential growth and decay. What we do know is that if we started at 600 and we have 300, then we know our rate should be negative. We know that k would be negative. So the first thing we need to do is go find k, I think. So let's go on ahead and input everything we know in terms of our equation. We know that we had, after some time, we had 300, and we know that we started with 600, and we know the time was equal to 3, and we don't know what k is, and that's what we're looking for. So we have the equation 300 is equal to 600 times e to the 3k. We're going to start off by dividing both sides by 600, and that's how I get 1/2 is equal to e to the 3k. Again, we're trying to get the same base. We can't. We're going to take the natural log of both sides. So when we take the natural log of both sides, we're going to have the natural log of 1/2 is equal to the natural log of e to the 3k. Using the third property of logs, I'm going to have the natural log of 1/2 is equal to 3k times the natural log of e. Remember, the natural log of e is 1, and then we can see that we're going to have to divide both sides by 3 to solve for k, and we find that k is equal to the natural log of 1/2 divided by 3. So remember that if you're going to put this in a calculator to get an estimate, I will have the natural log of 1/2. Make sure you close the parentheses on that natural log before you divide it by 3 and have that equal to k. I'm going to do this on the calculator to show you a couple of things there too. When you have problems like this and you may have to use k again, I'm going to use the store function. But for right now, let's go determine the value of k. I've highlighted what I need to find in my calculator, so I'm going to go find the natural log of 1/2. And notice I close my parentheses, and then I'm going to do divided by 3. And that will give me the value of k. And we can see that I have estimated the value of k to be negative 0.231. Alright, so now that we have that, and let's say I need to use this number again, which we will, I'm going to store it and I'm going to hit the stow key. It's located right on top of the on button. I hit stow key. It stands for storage, and it's asking me, do you want to store your answer as a letter? And the answer is yes. I'm going to store it as the letter K. So I'm going to go to alpha, which is the green button, and then go find the letter K, and now I have k is equal to that number. So I'm going to push enter, and it's in there. So check this out. If I just type in the letter k and press enter, it will tell me that exact same number. So let's go back to our problem so that we can see how we may have to use k the k value that we found. To finish this problem, we need to know how much substance is left after it's been 7 years. So I'm looking for how much is left. If we started with 600 and we know the rate, that's this number that we found down here, and we want to know what happens after 7 years. So now what I need to know is what is the y value. Notice I know the 600. I know E is just a number. K, I put a little asterisk there to realize that we do know that number. We have it stored in our calculator. We're going to show that in a minute. And then we have the 7 years. So we know everything. We just need to stick this in our calculator so that we can come up with the y value. So let's do that. So I want to remind you that we still have the value of k stored, and we can see that number there. So we're going to plug in 600 times, you can put the times or not, and then I'm going to do the second, and then I'm going to go to the ln because that's going to give me my e to the exponent, and my exponent will be 7 times k, and I'm just going to put alpha k. And notice that's all in the exponents. I really don't need that multiplication symbol either because it understood that it's going to be multiplying. I'll show you that in a minute when I push enter, and you can see how we are finding our value of 119.06 as an approximation. So what I mentioned before is that you can do 600 and then do second natural log to get e to the exponent. Then type in 7 times k, or k times 7. Make sure you get your alpha k, and then push enter, and we should get the same value. And that concludes this video.